I'm going to be talking about knowledge-based construction efforts for cancer genetics. This particular work is a collaboration with some clinicians and doctors at Mass General and Howard Med. And a big shout out to them in terms of doing the heavy lifting, in terms of collecting and annotating the data for us. So to begin with, I'll just give a brief overview of the kind of oncology literature that we are concerned with, which is known as the penetrance papers. These are the literature that describe the risk of any given type of cancer with respect to a particular gene or a germline mutation. So the key pieces of information that the oncologists are interested in are the ascertainment, that is the kind of population that was studied, and of course, what was the associated risk to that population for a given type of cancer. Ideally, they want to synthesize these key elements from these papers into a database. So the way that they're currently doing is that they go through these individual papers line by line. These PMIDs correspond to these penetrance papers, and they sort of fill in this table of gene and the associated risk for a given type of cancer. So the only issue with this laborious effort that they've been doing is that there's just too many of these studies. So like 16,000 or so of them appeared in 2019 alone. So our work sort of aims to somehow automate this data extraction process from the cancer literature to aid in knowledge-based construction. The first task that we focused on was the classification of ascertainment sentences. So these are the sentences that describe the demographic population on which these studies were carried out. So they often include words like the US population or Danish civil registration system, their race, sex, year of birth, and things like that. And then the next most prized possession of these penetrance papers is the risk estimates. So for example, the presence of BRCA2 or the caretaker gene in the body corresponds to a certain risk of having the breast cancer, and that risk is quantified through an odds ratio of 6.20. So these are the sort of things that these oncologists are interested in. So for the ascertainment classification task, you begin by taking the full text PDFs of these gene cancer studies, parsing them through a tool called Grabit, which gives us a vague XML representation of the document. And then using some neat regular expression tricks, you can sort of get a sentential representation of the entire document. On the sentential representation, you can sort of induce distance supervision over these individual sentences by comparing them to the available ascertainment mechanisms to create a set of positive labels, and then you can sort of treat this entire problem of ascertainment, identifying ascertainment sentences as a classification problem, and then you can use your favorite model. So naturally, if you use sort of transformer, it sort of seems to be like an overkill, but it does reasonably good job. The second, however, more interesting task is that of identifying risk estimates. So we again start with a sentential representation of these penetrance papers, these full text documents, and we pass them through a transformer like Cybert, or you could use Elmo here if you wish to. And then you get this contextualized representation of these individual sentences, and say you identify the two entities, E1 and E2, where E1 corresponds to a gene, say BRCA2, and E2 corresponds to an odds ratio. You take the localized representation of these two entities, combine them with the contextualized CLS token, and then pass them through a linear classification layer to sort of establish a relationship between these two entities. And that sort of gives you a germline mutation risk pairs. So you train this model jointly, and the loss function is just a cumulative unweighted sum of the unweighted log likelihood of these two tasks of identifying entities and identifying relation given those entities. And so this sort of gives you a joint entity relation model that through which you can extract these germline mutation and risk pairs. We benchmark this approach against a disjoint entity relation model, and it turns out we outperform it by a significant margin on the relation classification task, but in terms of the entity classification, these models are just the same. The funny thing here is that using Cybert, which is trained over scientific data, over BERT, gives us no significant gains. And with that, I think I'm out of time, so yeah, thank you.